Awesome. Yes, very, very short, 4 minutes. Thank you all for being here today. I'm going to talk a little bit about how this is the first step of a broader project to use wearable computers to look into gathering more information about how dogs can be injured while they're doing sports and hopefully take a big step towards preventing those injuries with wearable computers in the future. So for the uninitiated, canine agility is a sport where dogs run through obstacle courses with their human handler. It's the most popular and fastest growing dog sport in the world right now. Lots of people love doing this with their dogs. It's a great fitness activity for humans and dogs. But recent studies have shown, polling people who participate in agility with their dogs, that about 40% of dogs will be injured while they're doing agility at some point in their sort of athletic career. It should also be noted that dogs are just awesome and do really insanely athletic feats of performance while they're doing agility as pictured here. So as a first step towards this goal, we made a custom wearable activity monitor that's mounted on a collar. We made a custom circuit board with an accelerometer, barometer, Hall effect sensor, and a customized latching power circuit, so we can take user input for control from a magnet sort of far away. This is all optimized for like getting it on the dog and collecting data as quickly and as easily as possible, because when dogs are ready to run through an agility course, they're all hyped up and ready to go. You don't want to impede that. We're using ESP now to broadcast real-time wireless telemetry at 100 hertz. And yeah, you can see the collar there. It's on a breakaway collar, so if it gets snagged on anything, it just falls off. We did a pilot study with 4 obstacles, 3 distinct jump, tunnel, and A-frame. We had 6 trained agility dog participants, and as we were running the pilot study, we collected synchronized video and collar data. So from the pilot study data, we extracted labeled discrete windows that we did our classification experiment on. Since our pilot study was relatively small, we evaluated our machine learning classifiers on variations of k-fold cross-validation experiments and then took averages from those. So we've evaluated in both dog-dependent and dog-independent contexts to assess the performance of our classifiers. 2 other sort of variations that we tried here were padding the activities and not padding the activities. The first classifier that I tried using was a MINIROCKET multivariate transform that required the activities to be of the same length. So we took all of our discrete windows and padded them with Gaussian noise and used those classifiers. Since the work was published, we've actually extended that technique to be able to work on variable length data. So whereas our original results were 86 and 76% depending on the dog-dependent or independent context, we're now at about 94% with a dog-dependent context. So from here, we really have a long way to go before we can basically go from saying we can recognize the obstacles that the dogs are running through while they're doing agility, before we get to the point to say we can look at variations in those obstacles to actually detect injuries. But that's essentially where we're heading with this. And the next step from here to there is to transition to a continuous classifier rather than classifying on these discrete windows. We also want to do things like recognizing when a dog is leaving an obstacle early. They may jump from a height that is not necessarily safe from them, and we know those sorts of things can be a strong source of injuries. Also, this task has a distinct grammar, since there are orders to the obstacles that we could potentially know of a course beforehand. We can use that to do things like hidden Markov models that will help boost our classification accuracy by using that grammar. And then further, since we already have the video data, we can do things like incorporate markerless video tracking to look at fine-grained joint details as the dogs are doing these activities. Thank you so much for your attention. Any questions?
I was first. So this was my favorite paper during the East Week. So very nice work. So my question is since you mentioned your next step is to for injury prevention, but you will need to have data of those dogs that is going into kind of dangerous situations. So have you considered how to conduct this study?
We're not particularly trying to injure the dogs to get the data.
Yeah,
what we're counting on is actually the fact that most people are relatively, a lot of these injuries are very subtle, and most dog owners may not realize that injury at its onset. It may take a long period of time before the injury becomes obvious enough for your average dog owner to notice it. One of our really excellent collaborators in this work is a vet that's board certified for performance medicine in dogs. So she's been doing assessments, not with this pilot study, but with the broader data collection we've already done, where basically we do a vet inspects the dogs before they go run. We take polls of basically all of their conditions, and we also have a vet label the videos for us to say, well, this dog is showing signs of lameness here or in particular conditions. And then we use that in retrospect to sort of look at whether or not our classifier can sort of find those variations.
Perfect, thank you very much.
Mm-hmm. I have a poster in the back. Just come talk after this.
Okay. So let's bring all the speakers up for the panel. Since we're running late, here's what I decided to do. There is a video. Okay. The speaker isn't here. So what we'll do after the panel, just like we're going to have the posters in the back, people can watch the video in the front. That's like the best option I can think of. So because we're really running late. All right.